going to show you the setup for your calculator. So you are going, I'm sorry, your setup for your calculator when you need to graph polar equations. So you are going to click mode. You are going to arrow down. We're going to graph them on paper in radians, but it's easier to look at them in degrees on our calculator. We want polar. Okay. So that sets it up so that it'll actually change like your y equals and things like that. You are going to go to window. Theta min, the very first one, start it at 0. Theta max, go ahead and do 720. I mean, you could also, if you wanted to, you could do 1440. This is basically just telling, like, as long as you do at least 720 degrees, you're fine. It basically tells your calculator how many times it needs to go around the unit circle to actually graph this. Go by 5s, maybe 10s, maybe 15s. Don't go anything bigger than 15 for your theta step. If you go bigger than 5, or I'm sorry, if you go bigger than 15, it's going to make your graph look very choppy and weird. Your x min, anywhere from like -4 to, I'm going to put it at -6. Oh, I'm going to get yelled at because it's going to tell me that that's not real. Make sure you hit the negative button, sorry. To +6. And then your x scale can be 1. Same thing for your y min and your y max, -6 to +6. Guys, it's a little weird because your calculator doesn't look exactly the same as a polar graph when you go to graph it. It's basically telling you how many circles you've got on your graph. And your y scale is good, and that's all you've got there. Go to second window to set up your table. Start your table at 0. Change in table is 15. That means every 15 degrees is going to give you a point. And the reason we do 15 is because when we go to graph this on paper, we're graphing it on, a polar plane that has 0, 30, 45, 60. So it's got, like, we put the 15 in there. So anytime we have 45 degrees or 135 degrees or anything like that, then we can actually see where it's at. Okay, I think that's pretty much everything else. So then what you're going to do is if you go to graph it, you're going to hit y equals and notice how you got R1, R2. And guys, make sure, for whatever reason, sometimes you guys highlight plot 1 and that's going to yell at you. Please make sure you unhighlight any of those plots up there. I'm going to type something in. 4 minus 4 cosine, oopsies, whoa. I'm typing in cosine. You can't do that. Sorry about that. I'm doing this on the MacBook and I started typing in cosine. So sorry. Actually hit the cosine button, right? So I've got 4 minus 4 cosine, and here's your theta, xt theta n. X for when we're in function mode, t for when we're in parametric mode, theta for when we're in polar mode, and n for when we're in sequence mode. Okay? And then all you're going to do is hit graph. Okay? I obviously should have made this a little bit weird, a little bit bigger as far as -6 to +6, but that's okay. It doesn't matter. You just want to use the actual graph screen for a general idea of what it looks like. What you're going to do is you're going to do second graph and go to your table, and you are going to grab as many points as it takes to actually make the shape. So obviously when theta equals 0, r equals 0, right? When you go to theta equals 30, it's at 0.5. So basically you're going to go to 30 degrees on, find 30 degrees on the plane, and then, go out half of a circle. At 45, we would be at 1.17. At 60, we would be at 2. What you have to do, students always ask the question, how many points do I need? You need to keep arrowing down and doing every point that you can until your pattern goes back to the original starting point, like until you've actually got the entire pattern. Okay. And I will, when I go to actually do the notes, or when I do those notes, you'll see what I mean. So if you look at this, I have to go like, here's my 0, 0. Here's my, 30 and 1/2. Here's my 45 and 1.17, blah, blah, blah. Here's my 90 degrees and my 2 right there. I'm sorry, 90 degrees and 4 right there. I apologize. And I would just keep going around until I get back to um, something that gives me the actual answer. And remember, I don't know if you have any on this one or not. Let me go back to the table. No, we don't have any. Remember though, if we had like any of these radii were negative, remember that means that we find the angle and then we go in the opposite direction, right? I'm just scrolling up to see if any of them, I have negative angles, but not negative radii. Okay. So sometimes in the radius column, you will have negative numbers. Just remember that when you're plotting those points, you're really just going backwards. So basically, graphing these equations is basically just plotting a bunch of points, but instead of me giving you the list of points, you have to pull the points off your graphing calculator to get your picture.